Even with proper oil and the best filter system, problems can occur. As part of your maintenance practice, occasionally inspect filters to detect the beginning of serious engine problems. With a cartridge-type filter, the analysis is easy. Simply take the filter out and look at it. Spin-on filters, however, need closer inspection. Often a deformed spin-on filter, due to overpressurization, is the only sign an equipment owner has that a problem exists in the lube system. Deformed filters are the direct result of excessive lubricating system pressure, which is caused by a stuck or malfunctioning pressure regulator valve in the oil pump assembly. This problem should not be attributed to the filter. Gaskets are displaced from filters due to excessive lubricating system pressure, insufficient gasket compression, or a combination of both. Generally, if the gasket is properly installed, the filter will become deformed before the gasket is displaced. Inspecting the inner element may detect additional problems found in the lube system. If the media is covered with a thick, loosely held sludge, it is an indication of an excessive amount of fuel soot. This could be the result of a wide range of factors. Many can be readily eliminated by a mechanic who knows the vehicle. Coolant leakage or moisture contamination will cause wavy pleats in the media and deterioration of the wrap. It may also cause a sticky, shiny, tightly held sludge on the filter media. A deteriorated outer wrap is another sign of moisture. Certain oil additives will trap water and cause a gel-like coating on the filter media. It may appear clean, but when tested, will show a restriction if moisture is still present. Any wear debris on the media is a sign of trouble. An oil analysis can detect potential problems before catastrophic damage occurs. Lab technicians can detect changes in lubricant viscosity, whether it has thinned from fuel dilution or thickened from contamination. Tests can also check the acid neutralizing additive to make sure it's still guarding against corrosion. Flashpoint tests can indicate high fuel dilution. A measurement of insoluble particles will determine the contaminant level, and the final test for metallic content is invaluable in determining the location of wear in the engine. Keep in mind that although many improvements have been made in oil quality and additives, lubricating oil has a limited lifespan. Filters also have a limited lifespan. If they are run beyond their capacity, they can no longer provide protection to an engine. That's why establishing drain and filter change intervals to incorporate economy with maximum protection is ideal. Many factors must be considered when determining a proper preventive maintenance schedule. Charts and guidelines plotting recommended change intervals are available from the engine manufacturer. Always follow the recommendations, and before extending drain intervals, discuss it with your engine and oil suppliers. Engine parts will tell if a proper schedule is being followed. By reading the writing on cylinder walls, pistons, bearings, and other sealing surfaces, a fleet manager can determine whether his PM program needs attention. Oil-related engine failures generally fall into two categories. Rapid failures are tied to obvious problems like oil starvation, gross contamination, or mechanical breakage. It's more difficult to find a cause for gradual failures. They are characterized by accelerated wear or corrosion resulting from contamination, additive depletion, oil of the wrong weight or classification, or any combination of those causes. By applying some basic troubleshooting techniques, keeping good records, and adhering to maintenance schedules, you can avoid serious breakdowns.